The night in Alexandria smells of sea salt, resin, and wet rope, and this scent lingers in the air as stubbornly as numbers with nowhere to lie cling to memory. On the waterfront, where rats rustle in the shadows of warehouses and where guards tap their staffs to stay awake, a tall rectangular window glows faintly. There, above wax tablets and piles of papyrus, someone holds an oil lamp in their palms and looks up at a black dome dotted with dots like sparks scattered across fabric. The city doesn't yet know the words that children will later learn and pronounce with mechanical certainty, as if they were something as simple as a light year. And yet here, in the stone-cramped space between the port and the library, where scribes wipe their hands on the edge of their tomes and philosophers debate the nature of emptiness, begins a tale of distances that the mind tries on with effort, like a strange garment. People of this time know how to measure the world by their own standards. They know how many steps it is from the gate to the marketplace, how many stades from Alexandria to Conopus, how many days' journey downwind to Rhodos. Their state is supported by taxes and roads. Their wars depend on grain reserves and on how quickly a horseman can deliver an order. On such a scale, the concept is far from the tiredness of legs, the amount of bread in a bag, the chance of not being robbed at a mountain pass. Even the sea, which seems endless, is in reality subject to familiar rhythms, seasonal winds, currents, anchorages in bays, the price of ropes. When they speak of the cosmos here, they speak of its order, the harmony of the spheres, of how the stars are fixed to the celestial shell like nails in a dome. The dome may be enormous, but it is still a dome. You can rest your thoughts on it. And so, on this night, in a room with a lamp, someone recalls words that have long since become legend. That the sun is far and large, and the moon is close and small, that shadows on earth are uneven, that in Siena at midday on the summer solstice, wells have no shadows. These words belong to a man who looked at a stick and saw in it the measure of the planet. His name was Eratosthenes, and in his hands, numbers for the first time embraced the entire earth. He didn't circumnavigate the globe, he didn't sail to the edge of the ocean, but he made distance the result of reasoning, not a route. This was bold and dangerous. After all, if distance can be calculated without a road, then it exists separately from the human body, separately from the pain in the feet, separately from bread. Within such a distance, a person is no longer a master, but a mere point. But even Eratosthenes, even those who after him made geometry an instrument of power and commerce, remained in a world where distances were measured in earthly units, not in units of light. Light, in their minds, is neither a runner nor a messenger, but a quality, a ray, and a confluence. In a lamp, it flickers and smokes. On the sea, it glistens. On marble, it sharpens shadows. No one thinks of measuring a path by light, because a path is something traversed by feet, horses, and ships. Light traverses nothing, it simply is. However, even then, in Alexandria, where, under the vaults of the museum, they debated the workings of vision, a crack was beginning to appear. Some said that the eye sends out rays and probes objects with them, like a hand probes a stone in the dark. Others, that objects emit something, and this enters the eye. In both cases, light, no matter how you look at it, was linked to time, because entering and exiting are verbs of motion. And motion, even if instantaneous, forces the mind to ask whether it is truly instantaneous. This question could not become practical back then, because they lacked the means to trap light in time. But the question was asked, and it lingered in the air, like the scent of oil in a room. A century doesn't pass as they're depicted in school charts. It passes like a change of power at a port. One owner hangs out new signs, another takes the old chains, and the fishermen still set out at dawn. Rome takes the world into its grip, builds roads, pumps grain out of Egypt, fills amphorae with wine and oil, and distance again seems human. How many days does a legion march? How long does it take for post offices to change? How much does a horseshoe cost? In the provinces, people know the value of time, because time is delivery, it is tax collection, it is judgment and punishment. But the stars remain in the same place, and at night, when smoke rises from the camp and soldiers play dice, they look up and see the same scattering. When late antiquity begins to darken, the sky does not darken. It is still as bright in the deserts of Syria and the mountains of Asia Minor. In monasteries, Where books are copied and pens are sharpened, distance again becomes words. Far, high, incomprehensible. Those who think of the heavens think of signs and symbols, not numbers. But numbers don't disappear. They hide in astronomical tables, in calendars, in Easter calculations. And there, among these tables, lies the opportunity to ask the question of the speed of light again, though no one pronounces it that way. The light year will not be born the moment someone first utters these two words, but the moment when the speed of light ceases to be a philosophical shadow and becomes a measurable quantity. But for this to happen, the world must first learn to measure time differently. Not by an hourglass or by prayer, but by mechanics. And the mechanics of time are born from trade, from navigation, from wars, from everything that demands precision. European cities of the late Middle Ages grow. They acquire tower clocks that strike across the square and force people to live to a rhythm imposed by metal and gears. In these cities, distance again becomes an economy. How much fabric can be transported? How much salt? How much silver? And the sea again becomes a road. But now the road leads into the unknown, because the old maps are running out, but the thirst for spice and gold never ends. When ships begin to travel beyond their usual routes, when the compass and astrolabe become the tools of not only scholars but also captains, the sky becomes an instrument. The stars are not just lights, but points by which to steer a course. To do this, one must be able to measure angles, and therefore trust in geometry. And so geometry, the very same that once allowed Eratosthenes to embrace the earth, returns to the deck, where the scent of decanters and wet wood fills the air. It becomes a practice of survival. With this return comes a new boldness of thought. If the earth is measurable, if the sea is subject to calculation, then perhaps the sky too is. In the 15th century, a special mixture simmers in Europe: religious wars, printing presses, university disputes, the patronage of princes who desire glory not only on the battlefield but also in the offices of scholars. In such an environment, a man appears who looks at the planets and doesn't believe they simply revolve around each other for aesthetic reasons. He wants tables that actually work. He wants calculations to predict the position of Mars more accurately than prophecy, quietly, almost imperceptibly. In this thirst for precision, a new mental illness is born: the habit of considering the sky a place where distances and speeds matter. And then, in Prague, where alchemists search for the philosopher's stone and Emperor Rudolf surrounds himself with astronomers, again Kepler appears. He lives in a world where astrology and astronomy have not yet completely diverged, where a scientist can cast horoscopes to earn a living and simultaneously write treatises on the motion of the planets. His formulas are not about how far away the stars are, but about how Earth's close neighbors move. But each such movement is already a hint of depth, because movement requires space, and space requires measure. On the other side of Europe, in Italy, Galileo points his telescope at the moon and sees mountains. He looks at Jupiter and sees tiny dots around it, changing position from night to night. These aren't just lights, they're worlds revolving around another world. At that moment, the ancient dome cracks. If Jupiter has its own satellites, then Earth isn't the center of all rotations. And if Earth isn't the center, then where's the boundary? What holds the stars? They still seem pinned to the sphere, but the sphere begins to tremble. And yet, even Galileo can't tell how far away the stars are. He tries to measure parallax, the slight shift of a star against the background of Earth's other movements in orbit. If the stars were closer, this shift would be noticeable. But it's imperceptible, and that doesn't mean the stars are motionless. Something else follows. If the Earth moves, but there's no shift, then the stars are incredibly distant. Incredible is the word with which a person closes the door to a number that doesn't fit in his head. This was the New World's first encounter with what would later be called distances incomprehensible to the mind. Light years didn't yet exist back then, because there was no fixed speed of light. Light in Galileo's experiments could still be instantaneous, though he was already trying to capture it with lanterns on the hills. Everything is woven into his experiment: the simplicity of the concept and the limitations of human senses. 2 men with lanterns, 2 hills. Signal response. If the light is not instantaneous, there must be a delay. But the delay is drowned in the reaction of the hands, in the trembling of the fire, in the breath. Light slips away like a thief who passes by the guard, and in the darkness, the speed of light for the first time becomes prey not in the laboratory, but in the sky. In the 10th century, when Europe is growing with observatories, just as cities are growing stone walls, the Dacia resident Olya Rumor observes an eclipse of Io, Jupiter's satellite. These eclipses should occur regularly, like the strokes of a clock, but they happen a little earlier, then a little later. And this difference is connected with where the Earth is in its orbit. When the Earth is further from Jupiter, the eclipses are late. This means that the light needs time to travel the additional distance. There is a cold beauty in this. The time of light is measured not by hands, but by the movement of the planets, and human clumsiness is pushed aside for the first time. Rumor could not give an exact number in modern units, but it showed the main thing. Light is not instantaneous, it travels. And if it travels, then its path can be made a measure. In the 15th century, when the ideas of enlightenment spread across Europe and along with them armies and epidemics, when monarchs built academies and simultaneously executed rebels, science became a matter of state. The accuracy of measurements became part of prestige. They measured the arcs of the meridian, debated the shape of the Earth, sent expeditions to Lapland and Peru. A strange connection arises. To understand the sky, you first need to know the Earth accurately. And vice versa, to measure the Earth, you need to look at the stars. In this loop, the metric of a new world is born. Light, meanwhile, continues to become a number. In the 10th century, when industrial cities were smoking with factories, when railways stitched the state together, and the telegraph turned distance into an almost instantaneous signal, the idea of the speed of light ceased to be exotic. Physicists conducted experiments in which light reflected from mirrors, passed through rotating wheels, and the delay becomes a measurable quantity. And here a psychological revolution occurs. If the telegraph makes it so that an order can cross a country almost instantly, then light turns out to be even faster, but still not infinite. The world begins to sense that speed has a limit, and this limit is not human, but natural. But it is here that the first reason for the light year appears. A distance that the mind cannot comprehend. Man is accustomed to the idea that distance has an intrinsic value of time, expressed in experience. One day of travel means fatigue, a night's lodging, risk. 1 week means a change in the weather, the depletion of supplies, melancholy. But light has a different scale. In a second, it covers what a person cannot cover in a lifetime. And when distance is expressed in the time of light, the familiar connection, far is too long to suffer on the road, breaks. A light year sounds like time, but it means distance. This is a trap of language. The word year pushes the brain into a calendar, the smell of winter, the anticipation of spring, but in reality it is talking about the path that light travels during this time. The human experience of time in years is vast and filled with events, but the path of light in a year is a figure in which there is not a single event, because for light there is no fatigue and no stops. There is no human history within a light year, and therefore it does not cling to memory. And yet, in the 10th century, people appeared who for the first time began to measure stellar distances with numbers, not words. Friedrich Bessel measured the parallax of the star 61 Cygni. For the first time, the distance to a star becomes the result of observation, not philosophical assumption. It turns out to be enormous. Light travels from this star for many years, and at this moment, the light year becomes not a metaphor, but an instrument. Because so many years of light is a clear connection between the speed of light and distance. But it remains clear only on paper. Inside the head, it does not take shape. The paradox is aggravated by the fact that the human mind is designed for medium scales. It evolved among trees, animals, winters of hunger. It can estimate the distance of a spear throw, the time before a thunderstorm, the distance to the shore. Even the largest empires, which could think in thousands of kilometers, still lived within the boundaries of the planet. Their geography was enormous, yet closed. And a light year is a step beyond any closed world. It's not just very far away, it's so far away that the very concept becomes strange. When told that the nearest star is several light years away, the mind tries to imagine a way, but a road requires landmarks, stops, a change of landscape. Interstellar space is almost empty. There is no landscape in the human sense. There are no familiar signs for the imagination to cling to, and distance, devoid of images, becomes an abstraction, like a tax rate or a number in an account book. It can be calculated, but not experienced. In this same century, Europe and America are undergoing another revolution, imperceptible in everyday life, but crucial for our conversation. Light becomes not only a physical phenomenon but also a fundamental constant. Maxwell's theories link electricity, magnetism, and light into a single whole. The speed of light is built into the equation as a hidden signature of nature, and when the theory of relativity emerges at the beginning of the 20th century, the speed of light becomes the ultimate speed of information transfer. It's no longer just fast, it's the boundary of causality, and here the light year takes on another, almost mystical quality. This distance is equal to a year of causality for light. Everything beyond this is in a different time bubble relative to us. We see the past there. We never see an object as it is now. We see it as it was when the light left it on its journey. And here the historical narrative becomes almost cruel, because people who lived in different eras begin to connect imperceptibly across light years, although they don't know it. When somewhere in Europe in 1448 people die of the plague and light candles near icons, the light of these candles goes into space, but it is weak and drowns in the radiance of cities and stars. When in 1610 Galileo writes down the positions of Jupiter's satellites in a notebook, the light from his lamp also goes out. When in 1914 commands sound at train stations and trains carry soldiers away, the light from lanterns and windows also flies out. Each such photon carries an imprint of the event, but in space there are no spectators who could reassemble these imprints. This is another reason for misunderstanding. A light year turns history into a beam that departs and never returns. And human intuition, accustomed to cycles and returns, does not know what to make of this departure. However, the main drama begins not in philosophy, but in how humanity tried to tame these distances. In the late 10th and early 20th centuries, astronomy becomes a professional system with catalogs, photographic plates, standardized brightness scales. Observatories are built on mountains, where the air is clearer and the stars tremble less. There, in the cold of night domes, people work like cosmic bureaucrats. They record, compare, check, argue about calibration. Their life is unromantic. It consists of discipline, of long waits for a clear sky, of struggling with capricious instruments, and yet, it is precisely their routine that opens the door to monstrous distances. When Henrietta Leavitt in a Harvard observatory studies Cepheid variable stars in the small Magellanic Cloud, noting a connection between the period of brightness variation and the apparent luminosity. This discovery initially appears as just another neat pattern in a table, but it becomes a ladder into depth. If you know the apparent luminosity, you can estimate the distance from the apparent brightness, and suddenly, space ceases to be a set of points on a sphere and turns into a space with depth, where some stars are closer, others further away, where islands of stars exist within the galaxy. Edwin Hubble uses this ladder and shows that the Andromeda Nebula is not a cloud within our galaxy, but a separate, vast world of stars far beyond it. This distance can no longer be measured in human units. It requires thousands of millions of light years. And here the mind finally breaks down, because a million in itself is difficult to perceive, and a million light years is not just a million of something familiar. It is a million years of light's journey, that is, a million years of the past, staring at us from the darkness. Within such a scale, human eras become thin layers, like lines on a tree trunk, and the state is like dust blown away by the wind. But the brain resists this humiliation and therefore prefers to perceive light years as a beautiful phrase, rather than as reality. History does not end with the discovery of the expansion of the universe. It becomes even more intense, because the further you look, the more the past presses on the present. An astronomer, looking through a telescope, sees not now, but then. If an object is billions of light years away, it is seen as it was when there were no people on Earth, and perhaps not even oxygen in its current form. And this is another blow to intuition. We are accustomed to the fact that vision shows the present. In ordinary life, the delay in light is negligible, and the brain ignores it. But at cosmic distances, vision becomes archaeology, looking turns into excavation, and then any word about distance automatically becomes a word about time. Here another ancient human habit enters the story: confusing a map with a territory. On maps, distance can be compressed. The entire ocean fits on a table, all of Eurasia on sheet. Telescopic images do the same. Galaxies separated by millions of light years appear side by side in a single photograph. The eye sees them side by side, but the number says, unimaginably far. The psyche chooses the eye. Therefore, the light year doesn't fit. It doesn't correspond to the visual sense of scale. We see the universe as a pattern, not a space, with a void between the elements that requires light to traverse it over years and millennia. And yet, there are moments when the light year almost becomes sensory, when it touches the earth through the drama of technology and war. The 20th century, with its total conflicts and industrial might, forces physics and astronomy to serve the state. Radar, radio astronomy, computers. All this is born in the atmosphere, where precision means advantage. Radio waves, like light, have a finite speed. Their delays measure the distance to the planets. For the first time, distances in the solar system are being measured not by parallax and angles, but by the signal's travel time. A person sends a pulse into the sky and waits for a response. He sees time, transformed into distance in much the same way that a light year transforms a year into a measure of distance. This connects everyday experience with the cosmic scale, but only formally. There, the delay is seconds and minutes; here, years and billions of years. At the same time, laboratories are refining the speed of light ever more precisely, until, at the end of the 20th century, it is enshrined as an exact value in the system of units, making the meter a derivative of light. This is almost a poetic revolution. Distance on Earth is now determined by light, the very phenomenon that extends into space. The meter becomes a piece of light's path, and therefore, the shadow of a light year. But this poetry is dry and cold, because it contains no human journey. There are only a constant and a cathode ray clock. If history were an honest play, it would give people a chance to get used to new scales. But history works differently. It throws new quantities at the head faster than the head learns. At the end of the 20th and beginning of the 21st centuries, cosmology begins to talk about billions of light years, as casually as grain traders spoke of thousands of measures. Maps of the cosmic microwave background appear, diagrams of large-scale structure, catalogs of exoplanets. A person sitting in the kitchen with a phone can see a photo of a galaxy hundreds of millions of light years away and scroll through it like someone else's photo. And this accessibility, paradoxically, deepens the misunderstanding. When the incredible is presented effortlessly, the brain doesn't activate the mechanism of respect for magnitude. The light year turns into a decorative word, a marker of the cosmic, and loses its heaviness. But it does have heaviness, and it is connected with the fact that a light year is not just large, it destroys the usual supports of perception. In human life, distance is usually associated with the possibility of interaction. If I can walk, I can influence. If I can drive, I can trade, fight, love. The light year says, interaction is limited by the speed of light, which means that beyond a certain limit you can't do anything quickly. At a distance of several light years, even the fastest signal means years of waiting. This breaks social intuition, because the human social world built on relatively instantaneous feedback. A word, an answer, a gesture, a reaction. At light distances, feedback turns into emptiness, and emptiness is what the psyche fears. And now, when the word light year already exists, we can go back to the beginning and see how long humanity has been working towards it. It went through cities and ports, through monasteries and observatories, through wars and expeditions, through mechanical clocks and the telegraph, through Maxwell's formulas and Romer's measurements, through Bessel's parallaxes and Leavitt's distance ladder. Each step expanded space, but each step made man smaller. And this is the hidden conflict. Man wants to know, but knowledge diminishes his centrality. Therefore, the light year as a unit is perceived not only by the mind, but also by pride and fear. In one sense, a light year is a very simple thing. The distance that light travels in a year. But the simplicity here is deceptive, because a year is not a unit of space, but a unit of life. It is filled with holidays and illnesses, deals and breaks, rains and dry winds. Even in ancient times, the year was a circle. Sowing and reaping, the Nile's flood and ebb, birth and death. A year is a cycle, and distance is a line. The light year connects cycle and line, forcing the brain to simultaneously hold two incompatible forms. It says, take the circle of time and stretch it into a straight space. It's like trying to imagine smell as sound or color as temperature. You can learn the correspondence, but you can't make it natural. In the era of sailing ships and mail coaches, a year's journey was already almost impossible for the average person. It was something from the lives of merchants, pilgrims, soldiers, settlers. In the age of airplanes, a year's journey has become absurd. In a year, you can fly around the world hundreds of times. And so the expression, a year's journey of light, turns into a strange relic, as if we were talking about a creature that runs without stopping and does not age. Light is not a traveler in the human sense, but language makes it a traveler. We say, light flies, we ascribe will, direction, and history to it. And this metaphor works as long as distances are short. But when it comes to light years, the metaphor breaks under its own weight. Light travels for millions of years, unchanged and unaware, a journey without a traveler. It's hard to imagine. And yet, people try to imagine it. They draw comparisons. Flying on a plane, driving a car, or a ship going non-stop. These comparisons inevitably fail because they return distance to a human scale. And a light year is precisely the exit from it. Plane, car, ship. They all depend on fuel, on repairs, on food, on sleep. Their speed is social, it requires infrastructure. Light needs nothing. Its speed is not technological, but anthological. And this makes the mind feel an abyss. To understand a light year, one must momentarily become not human, but a law of nature. In ancient times, the distances of the world were associated with power. The empire existed as long as a courier could deliver an order quickly enough, as long as a legion could reach the border, as long as taxes could be collected and delivered. A light year is a distance over which power is powerless. No emperor, no state can speed up light. There's a quiet humiliation in this, unacknowledged but felt deep down, like the cold of stone. And so the word light year often sounds in speeches as a sign of greatness, as if we're speaking of the incredible, we're above the mundane. But in reality, it speaks of a limit, of how even the most powerful mind is limited by physics. In the 20th century, when humanity first sent spacecraft to other planets, distances within the solar system began to take on an almost mundane character. So many minutes to the moon, so many hours to Mars by radio signal. This delay makes space tangible for the first time. The command doesn't arrive instantly. The spacecraft responds with a pause, like a person thinking. The pause grows with distance, and in this pause, the taste of light as a measure emerges. But the light year remains beyond our grasp. It's too vast for delay to become part of everyday experience. Even when talking about the nearest stars, the response delay is years. You can't live that long within a single project, a single career, a single political era. People make plans for years, but these plans require feedback within those same years. The light year transforms feedback into a legacy. This is why astronomy is so closely tied to archives and catalogs. It demands a long memory. It demands institutions that outlive people. And this holds a special historical drama. Knowledge about light years is created not by lone heroes, but by systems that survive revolutions, regime changes, wars, fires. Observatories burned, instruments broke down, funding disappeared, scientists emigrated or died, but the sky remained. Light from the stars traveled to the earth, knowing no boundaries, and this made its indifference almost insulting. However, light years are not only about indifference, they are also about the fragility of observation. A person thinks they're looking at a star, but they're actually looking at a photon that has survived a journey through the void, passed through interstellar dust. Perhaps it was deflected by gravity, perhaps it passed by fields unknown. This photon is a messenger carrying a letter without an envelope, and the letter could be damaged along the way. The greater the distance, the greater the chance that the signal will change. And so a light year isn't just a long time, it's also uncertain. At enormous distances, Everything we know becomes probabilistic, statistical, and dependent on models. This creates tension within human psychology. We crave absolute certainty, and the cosmos offers it reluctantly. When large telescopes were built in the first half of the 20th century, their domes became symbols of a new era, much like cathedrals in the Middle Ages. But unlike cathedrals, which were built for community and for God, observatories are built for data. Inside them, people work at night, like guards at the wall. Their enemy isn't an army, it's atmospheric turbulence. It's the air, subtle alignment errors, their weapons, glass, metal, mathematics. And every millimeter of precision makes it possible to say, this isn't a nebula, this is a galaxy, this isn't a star, this is a supernova, this isn't noise, this is a signal. Behind every such statement lies a distance in light years, which seems to get a little closer to understanding. But in fact, understanding doesn't get any closer. Only the ability to operate gets closer. There are moments in human history when numbers become part of mass consciousness. This happened with percentages and inflation, this happened with kilometers and the speed of cars, this happened with megabytes and gigabytes. Light years also became part of language, but they didn't become part of sensation. They are used for hyperbole. Far away, like the stars, entire light years. This is another reason for misunderstanding. The unit becomes an embellishment of speech. It loses discipline. And discipline is needed because a light year is not very far. It is a specific number of meters. When discipline disappears, so does the chance to even intellectually grasp the scale. Discipline returns in places where truth depends on it. In cosmology, distances are associated with redshift, with the expansion of space. Here, a light year becomes not simply a measure of the path of light in static space, but part of a more complex picture. Space itself stretches, and therefore distance can be defined in different ways. As distance in the time of light, as distance now, as distance at the moment of light's emission. These distinctions are unnecessary in everyday speech, but they reveal yet another chasm between intuition and reality. In everyday life, space does not expand, distance is one. In the cosmos, on large scales, distance becomes a matter of definition, and the mind, seeking to rely on simplicity, slips again. But historical narrative has no right to composure. It must show how, in each era, people were confident that they held the truth, and how the truth slipped away. In the 15th century, they confidently spoke of spheres, in the 17th, of subtle ethers. In the 19th century, about mechanical models of light in the early 20s, about motionless space and time, until relativity shattered these beliefs. Each such shift is a small revolution in psychology. And the light year as a unit lives in this flow. It seems stable because it is linked to the speed of light, but the very meaning of distance on a cosmic scale turns out to be fluid. This makes the light year even less intuitive. It looks like a rigid ruler, but it is applied to fabric that stretches. At some point in the mid-20th century, people began to speak of cosmic distances with a new intonation, because the possibility of going beyond the Earth appeared. Satellites, rockets, the first flights. All this gives the body the experience of space, weightlessness, the view of the Earth from afar, a black sky without the blue daylight filter. But even these are not light years. They are only hundreds of kilometers, thousands, millions. A person in a capsule feels incredibly far from home, although in reality, they are closer than any ancient traveler to the neighboring continent, if we consider the time of communication. And this illusion of distance shows how much perception depends not on numbers, but on conditions, on danger, on isolation, on the impossibility of breathing air without a life support system. A light year does not impose such conditions. It is a pure number. Because of this, a light year cannot become part of an emotional map of the world. We can fear the depths of the ocean because it is dark and pressurized, and because it contains monsters in our imagination. We can fear mountains because there is cold and rockfall. We can fear the desert because there is no water. Interstellar space, light years away, does not evoke concrete horror. It is empty. But emptiness on this scale is not the kind of emptiness one might imagine as an empty room. It is an emptiness that itself becomes an object, almost like the ocean, but without water. And it is precisely the absence of an image that makes fear impossible, and without fear there is no sensation. So the light year remains skinless, odorless, and temperatureless. Meanwhile, in scientific circles, light years are becoming the everyday currency of conversation. And herein lies a subtle social phenomenon. People who operate on such scales begin to belong to a special caste, not by blood, but by language. Their work requires abstract thinking, patience, and the ability to live within models. It's similar to how priests in ancient temples could read signs inaccessible to ordinary people. But now the signs are not divine, but physical. And like any caste difference, it breeds alienation. Light years become not only incomprehensible but also alien, belonging not to the world of human affairs, but to the world of specialists. This is another layer of misunderstanding. The unit lives in speech, but not in experience, and therefore seems artificial. The historical paradox is that it is precisely this artificiality that makes the light year useful, because it frees us from human scale. It allows us to speak of the cosmos in the language of the cosmos. It allows us to leave behind the kilometers associated with earthly roads and borders. A light year has no states, no meridians, no customs. It has only the speed of light and time. And there is something almost ancient in this, a return to the sky as an absolute. Only now the absolute is not religious, but metrological. But even metrology does not save us from the main thing. The mind cannot understand a light year because it cannot grasp scale without reduction. It tries to reduce, to find an analogy, to reduce to the familiar. And every time it reduces, it loses precisely what makes a light year, its alienness to the human world. When they say that a light year is approximately 10 trillion kilometers, the brain sees the word kilometer and calms down, as if it were still a road, just a longer one. But a trillion is no longer a road, it is the accounting of the universe. When they say a year of light's journey, the brain sees a year and thinks of days, months, holidays. But light has no holidays. Any attempt to tame the unit makes it false in its perception. And yet, there remains a final scene in which the light year seems to reveal its true face. Not through numbers or metaphors, but through the fate of stars. Because at great distances, we see objects that could have already disappeared. A supernova could have flared and died, a star could have turned into a neutron star, a galaxy could have collided with another, and only now are we seeing the light that announced it. It's like a letter that traveled for centuries and arrived after the sender's death. History knows of such letters, messages from besieged cities, diaries found centuries later, archives opened after the fall of regimes. They always make a special impression, because they speak from a past that can no longer be changed. The cosmos does this constantly. It speaks to us with the voices of processes long past. And a light year is a measure of the delay in this conversation. Ancient chronicles describe new stars appearing in the sky. Chinese astronomers carefully recorded such phenomena because they were considered omens. In Europe, they were also noticed, but often feared to interpret them because the starry sky was considered perfect and unchanging. When a supernova exploded in 1054, it was seen during the day. Back then, no one could say that this event had occurred thousands of years before it was seen. No one could say that the explosion was thousands of light years away. People saw a sign and associated it with emperors and warriors. They couldn't connect it with the fact that the light had been traveling to them for millennia. Today, we can say that this is light that has traveled a long way, and that is why we see the past. But saying this doesn't mean understanding it, because in human history, thousands of years represent the change of languages, religions, and borders. But for light, thousands of years are simply a journey. This gap between the richness of human time and the emptiness of physical time is the nerve of the light year. And this nerve is felt in every step of science, when it encounters the fact that observation is always the observation of the past. In the laboratory, you can almost ignore the delay in light. You can consider the measurement to be happening now. In astronomy, now disintegrates into layers. The moon is a little earlier, the sun even earlier. The nearest stars are years ago, distant galaxies billions of years ago. The universe becomes a slice of time, and a light year becomes the thickness of this slice. A person accustomed to living on the single plane of the present is suddenly forced to live in the volume of the past. They may adjust to this intellectually, but their emotions remain on this plane. At this point, the historical narrative returns to Earth again, because any misunderstanding has social consequences. When people begin to talk about cosmic distances, their sense of their own history changes. In the 10th century, influenced by geology, they for the first time truly accept the idea of the antiquity of the Earth. In the 20th century, influenced by cosmology, they accept the antiquity of the universe. Light years become part of this antiquity because they connect space and time, and this influences philosophy, literature, and politics, even if indirectly. The idea that the world is vast and ancient makes human conflicts simultaneously comical and tragic. But the brain protects itself from this duality, retreating into the mundane, the immediate. Therefore, even in the age of space telescopes, most people live within a radius of a few kilometers of their lives, and a light year remains somewhere behind glass. Glass is not a random word. Telescopes, lenses, mirrors. All this glass makes the distant visible. But glass does not make the distant close. It only makes it accessible to the eye. This is the key to strangeness. We see what we cannot experience. We have visual access without physical participation. In everyday life, seeing and being near are often linked. If you see a house, you can approach. If you see a person, you can speak. In space, seeing does not mean being able to approach. A light year is a measure of this impossibility. It says, you see because the light has reached. But reaching it yourself is a different story, not promised by physics, and hidden within this lies a melancholy that is rarely acknowledged. A melancholy for an impossible journey. But melancholy is not the only feeling. There is also a feeling akin to vertigo, when the mind tries to grasp two scales simultaneously, the size of a human life and the size of cosmic time. In the 15th century, people read about infinity and experienced religious awe. In the 20th century, reading about billions of light years, they experienced scientific awe. But awe is not the same as understanding. Awe is a reaction to a boundary. The light year marks the boundary beyond which familiar cognitive tools cease to function. And yet history continues to push humans toward these boundaries again and again, because this is the strange nature of knowledge. It is not satisfied with the familiar. Each generation builds more precise instruments, longer interferometer baselines, more sensitive detectors. It captures photons that were flying toward Earth even before the first cities appeared. It builds models of dark matter and dark energy, trying to explain why expansion is accelerating. And at every step, the light year remains simultaneously convenient and incomprehensible, as if the universe itself were pushing a unit onto us, one that allows us to speak but prevents us from calming down. Somewhere in the modern mountains, in an observatory where the air is thin and the night chill creeps under our jackets, a telescope operator stares at monitors. He sees graphs and images, sees spectra where the lines are red shifted, and from these lines, he can calculate the galaxy's recession speed. And from this speed, he can quantify the distance, billions of light years. He can say this calmly, because calm is essential to his work. But if he were to imagine for a moment that these billions of years represent a time comparable to the lifetime of the universe, that the light left when the Earth was still young, that the entire human race is the thinnest film at the end of this journey, he would find it difficult to press the buttons. So he doesn't imagine, he works. Science demands that people learn to stop feeling where feeling interferes. And this is also the reason why light years are not understood. They demand from us either inhuman emotional endurance or the renunciation of sensation. And yet, a strange echo of antiquity remains in the language. When the ancients looked at the sky, they saw fate and order. When moderns look, they see distance and time. But in both cases, the sky is a screen on which man attempts to read himself. The light year, despite its aridity, becomes a new symbol of the incomprehensible. Only now the incomprehensible is not mystical, but metrical. It does not promise meaning, it promises scale. And scale, devoid of meaning, is perceived as emptiness. And the mind, which has always sought meaning in the stars, must now learn to live with an empty scale. At this point, the story can return again to Alexandria, to the room with the lamp, because this dilemma was already there among the papyri. What to do with numbers that transcend experience? Eratosthenes embraced the earth with a number, and this number was enormous, yet still embraceable. Earth is home. It can be imagined. The light year is an attempt to embrace the darkness between houses we'll never see up close. It's a number unrelated to home, unrelated to the body, unrelated to power. It's associated only with light, which moves indifferently forward. If we continue this line further, we'll see that the light year is only the first threshold. Beyond it come parsecs, megaparsecs, units, even more alien to human time. But it's the light year, with its word, year, that deceives especially subtly, because it feigns familiarity. It's like a bridge between human life and the cosmos, and that's why it deceives. People think they've almost understood, but in reality they've simply learned a new word for something that remains beyond experience. Somewhere around the end of the 19th century, when electric streetlights appear on city streets, light becomes part of industrial power. It displaces night, makes the streets safer, extends the workday. People begin to perceive light as a resource, a commodity. This changes psychology. Night is no longer absolute, it can be bought. And in such a world, it's especially strange to hear that light is also a measure of the abyss, that its speed is a limit that can't be paid for or accelerated. Light, which is subject to a switch outside, becomes an independent force in space. This ambiguity also hinders understanding. Domestic light and cosmic light are the same physical phenomenon, but completely different in meaning. A light year thus exists between two lights, the light of a lamp and the light of a star. The lamp burns here and now, the star shines then and there. And language forces them to meet in a single unit. But this meeting doesn't occur in sensation, because the lamp is too close and the star is too far away. We can imagine a year in the life of a lamp, we can imagine how the wick changes, how the glass darkens, how the oil runs out. We can imagine a year in the life of a person. But we cannot imagine a year in the life of light, because light doesn't live, it simply moves. And when a person utters the word, light year, they utter a word that contradicts itself on the level of intuition. A year without life, a path without a traveler, a distance expressed in time. This word is a compromise between mathematics and poetics. Mathematics demands precision. Distance is equal to the speed of light multiplied by a year in seconds. Poetics demands an image. A year is a circle, light is a beam. Compromise works in speech, but not in the mind. History, if you listen carefully, always tells the story of how people tame abstractions, turning them into institutions and habits. Money, laws, calendars, the state. All these are abstractions that have become reality through practice. The light year has not yet become such a reality because people lack the practice of living in light years. There is no trade in light years, no politics in light years, no everyday life in light years. There is only science and imagination, and science requires the suppression of sensation, and the imagination of images that emptiness does not have. Therefore, the light year remains strange. It exists in calculations and in conversations, but not in muscles or memory, and yet, it constantly returns to culture because it is convenient as a symbol of the impossible. It sounds beautiful, it sounds definitive, it is a measure that seems to say, here is the limit, here is the value that puts a person in his place. And this symbolism, oddly enough, is historically accurate. Every time humanity expanded its world, it encountered quantities that refused to be human. In ancient times, such a quantity was the circumference of the earth. In the era of oceanic discoveries, the width of the ocean. In the age of industry, the speed of an electrical signal. In the age of cosmology, the light year. And then, on even larger scales, distances begin that are not even expressed in light years, because the numbers become too unwieldy. And then the ancient device returns again, to call the incomprehensible something else, so as not to feel it. But the light year remains in the middle of this history as the first truly mass sign of the cosmic abyss. A sign that entered language and failed to become part of experience is as if language had reached into the darkness and felt a cold vacuum. Stars still hang over Alexandria, though the library of Alexandria itself is long gone, and the stones on which the copyists walked have long since been ground to dust. The light from these stars continues to travel, and some photons that left their sources when Rome was still a republic arrive now, fall on the mirrors of telescopes, and are transformed into numbers in computers. Within these numbers are distances expressed in light years. And these distances can be named, written down, compared. But naming doesn't mean handling. Handling can only be something that has weight and shape. A light year has neither weight nor shape, and therefore remains what it was from the very beginning, a number that makes the cosmos measurable, but not intimate. And this tension between measurability and incomprehensibility stretches through the centuries, like a thin thread of light that does not break, because in emptiness there is nothing to break it, and because emptiness itself, oddly enough, turns out to be the most stubborn content of the universe.